Every app on your phone just got quietly rewritten. Your email, your search engine, your camera, your bank, all of them now run on the same technology. One idea, published in 2017, changed everything. And the wildest part? That idea is embarrassingly simple. Right now, large language models, LLMs, power ChatGPT, Google Search, Siri, customer support bots, medical diagnostics tools, coding assistants, and about 1,000 other things you use today without realizing it. They write legal contracts, they summarize meetings, they generate images from text. Companies are spending tens of billions of dollars a year building them. Governments are writing laws about them, and most people, smart, capable people, still don't really know what they are or how they work. That changes today. No math, no jargon, just the actual idea explained, so it sticks. Here's the simplest way to understand an LLM. Open your phone. Start typing a text message. See those 3-word suggestions above your keyboard? That's a tiny language model. It's predicting what word comes next based on what you've already typed. Now imagine that same system, but instead of training on just your text, it trained on basically the entire internet. Every Wikipedia article, every book that's been digitized, every Reddit thread, every news story, billions and billions of pages of human writing. That's an LLM. It is at its core a next word predictor. You give it some text, it predicts what text should follow. That's it. That's the whole trick. But here's where it gets interesting. When you make a next word predictor big enough and train it on enough data, something unexpected happens. It stops just predicting words and starts acting like it understands things. It can answer questions. It can write poetry. It can solve logic puzzles. It can explain quantum physics to a 5-year-old, all from predicting the next word. So, what actually made this possible? Before 2017, language AI was pretty bad. It could handle short sentences but lost track of anything longer. It was like talking to someone with a 5-second memory. Then a team at Google published a paper with the title, "Attention is All You Need." And that paper introduced something called the transformer architecture. Here's the non-technical version of what it does. Imagine you're reading a sentence. The cat sat on the mat because it was tired. What does it refer to? The cat, obviously. You know that instantly. But old AI systems struggled with this because they read words one at a time, left to right, like a typewriter. By the time they got to it, they'd half forgotten about the cat. The transformer doesn't read left to right. It looks at every word in relation to every other word, all at once. It builds a map of connections. It connects strongly to cat. Sat connects to mat. The model can see the whole sentence, or the whole paragraph, the whole document, as a web of relationships. That ability to look at everything at once and figure out what connects to what. That's called attention, and it's the reason these models suddenly got so good so fast. The transformer was the breakthrough, but scale is what turned it into something that feels like magic. And by scale, I mean 3 things: more data, more computing power, and more parameters. Parameters are basically the knobs inside the model. The more knobs you have, the more patterns the model can learn. GPT-2 in 2019 had about 1.5 billion parameters. GPT-3 had 175 billion. The latest models reportedly have over 1 trillion. Each generation gets dramatically better. Not because the core idea changed, but because the models got bigger and trained on more data. This is why tech companies are spending ungodly amounts of money on specialized computer chips and massive data centers. Training these models requires a staggering amount of computing power. We're talking about facilities that use as much electricity as small cities. The race to build the biggest, best LLM is one of the most expensive competitions in the history of technology. So, if LLMs are just predicting the next word, do they actually understand anything? This is the million-dollar question, and honestly, nobody fully agrees on the answer. What we know, they are spectacularly good at pattern matching. If the answer to your question exists somewhere in the patterns of human writing they trained on, they'll probably get it right. They can translate languages, summarize documents, write working computer code, and hold conversations that feel genuinely natural. What they struggle with: they can confidently say things that are completely wrong. This is called hallucination, because they're predicting plausible-sounding text, not checking facts against a database of truth. They can invent fake citations, make up statistics, or give you medical advice that sounds great but is dangerously incorrect. They also have no real-world experience. They've never touched grass, tasted coffee, or felt pain. Everything they know comes from text. Think of it this way: an LLM is like someone who has read every book in the library but has never stepped outside. Incredibly knowledgeable in a certain sense, but missing something fundamental about the world. Here's what I think most people get wrong about this technology. The debate is always framed as, are these things intelligent or not? And I think that's the wrong question entirely. What LLMs actually proved is that prediction and understanding might not be as different as we thought. We assumed you needed real comprehension to write a poem or debug code or explain history. Turns out a machine that's insanely good at predicting patterns can fake it well enough to be genuinely useful, and sometimes better than useful. That's not a statement about consciousness. It's a statement about us. It means a huge chunk of what we call knowledge work, writing, analyzing, summarizing, translating, might be more pattern-based than we ever wanted to admit. And that's uncomfortable, but it's also why LLMs are reshaping every industry at once. They didn't crack intelligence, they cracked the pattern layer of intelligence. And it turns out that layer handles a lot of what we get paid to do. The companies that understand this distinction will build useful tools. The ones that don't will either overhype these models into disappointment or underestimate them into irrelevance. So that's the core idea. LLMs are pattern-matching prediction engines built on transformers, scaled to an absurd degree, and they're restructuring how every industry operates. Whether that excites you or terrifies you probably depends on what you do for a living. If this helped you understand something that felt confusing before, hit subscribe. We break down tech like this every week. No jargon, no fluff. Next time, we're looking at how these models actually get trained and why the data they eat matters more than you think.